Okay, next atom model is Rutherford atom model. Rutherford proposed this atom model based on an experiment called Alpha Scattering Experiment. Now let us check what is the experiment. Okay, here is the setup of Alpha Scattering Experiment. Here they used a radioactive source which produces alpha particles, and it is scattered or it is incident to a gold foil, thin gold foil. Before incidenting it to the gold foil, the scattered alpha particles are passed through a lead slit to make a beam of alpha particles as shown in the figure. Okay, next the observation shows that, and next the figure, there is a ZNS screen, zinc sulfide screen, which is a fluorescent screen which will produce scintillations or flashes when alpha particles incident on it. Okay, these directions as shown in the figure represents the scattered alpha particles. There are small angle scattering, large angle scattering, even backward scattering. Okay, this was the experimental setup. Next, the slide explains experiment. I already explained. He used a radioactive substance which usually emit alpha particle. Alpha particle is helium-2 plus, that is, it is positively charged. Alpha particle could scatter easily. So again they used a slit to converge or to make it a beam of alpha particle as shown in the above figure. Then the beam of alpha particle hit the thin gold foil. We are using a gold foil, remember it. The gold foil is surrounded by a zinc sulfide screen as shown in the figure. Zinc sulfide is used to show the scintillations or flashes when alpha particles hit it, as I discussed. Okay, these are the observations they made. First one is, most of the particles moves straight after passing the gold foil and hit the zinc sulfide screen. Some deflected at a larger and smaller angle as shown in the diagram, and only few were deflected back. These three are the major observations made by Rutherford and his co-workers. Next, from this observation they concluded. Okay, before the proposal of Rutherford atom model, there is an existing model called Thomson's model, and according to this model, atom is a positive sphere, that is a plum pudding model. Atom is a positive sphere with negative electrons in it. Okay, so when alpha particles, which is positively charged, hit the positive sphere, according to Thomson, atom is a positive sphere. Then when alpha particle, that is, which is also positive, hit the positive sphere, what will happen? It must repel. There is a repulsion. Then most of the alpha rays should have been deflected back. But that didn't happen as we observed. What we observed actually, most of the alpha rays passed through the gold foil and moved straight towards the screen. Only few were deflected back. So there is some problem in Thomson's model, and Rutherford concluded that most of the space in atom is empty. That is why most of the alpha particles move straight and incident on the zinc sulfide screen. Okay. Next observation they made, there are some deflected at large angle and some at a shorter angle. Then why this observation, and what conclusion they made from this observation is, he concluded that atom have positively charged sphere at its center, that is called a nucleus, and its dimension is about 10 raised to minus 40. Unit is the meter, 10 raised to minus 40 meter. So most of the mass is concentrated in this nucleus and the electron surrounds the nucleus. This was their second conclusion, that is there exists a center nucleus. Before this conclusion, there was no existing theory predicting the concept of nucleus, and Rutherford made the conclusion first about nucleus. Okay, this was the second conclusion, and next observation was only very few deflected back. Why this happened? They explained, when alpha particle, which is positively charged, hits the nucleus, it must repel. Okay, positive repel. He said that only very few alpha rays deflected back means the nucleus is so smaller than atom. That is, size of nucleus is very small compared to that of atom. I already mentioned it is about 10 raised to minus 14 meter. Okay, next conclusion about electron, how they behave. For the atoms will be stable, the electron must be revolving around the nucleus in closed orbits, so that the centripetal force due to rotation of electron is balanced by electrostatic force of attraction between nucleus and electrons. That is, electrostatic force must be equal to the centripetal force of electron due to rotation. That is the condition for stability. Okay, these are the 4 conclusions they made from the experiment. Okay, this model is also is well accepted, but there are some drawbacks too that we will discuss soon.